Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 2 of lesson number 8, motion. So if you all remember, as part 1 was the introductory part to the lesson, I have introduced many terms to you all in part 1 and I hope every one of you might have taken a note of it as well, right? So I want you all to revise them first and then we will be like starting with the exact lesson in this part. But make sure you know the terms, you know the meanings of the terms. So please go through whatever notes you have taken in your book, everyone. So I hope every one of you have revised like whatever we have done in the last class, right? Where we had like so many terms that we have discussed about speed, time, then average speed, spontaneous speed, how to calculate them, what is the formula for calculating it, what exactly motion is, right? So like I hope you all have even understood what was exactly there in part 1, right? Now we will be like starting with part 2 where we have more information on motion. So like we will be starting it by describing motion, because once we start learning about motion you should be knowing how to describe it, what exactly motion is, right? And this lesson is something that you can learn through like observing your surrounding as well. Like the daily life examples, if you go through, you will understand it well and you will have a proper vision of like what are the different types of motion which are visible around us. Okay, so see, motion means movement, and in everyday life we see some objects at rest and some others in motion, right? If you remember, I gave you one example where for someone you are at rest, like for you are at rest, but for the other person you're moving, right? So sorry. So like motion can be very different. In everyday life you will see the things which are not moving around you, they are at rest, right? The objects are at rest. But once it moves from one place to another, we say that the object is in motion. right? So how can we define it? Motion is a continuous change in the position of an object with respect to a stationary object. What they have said, motion is a continuous change. Now, where is this continuous change taking place? In the position of the object. So, over here, the object is going to change from one position to the other. And now, how when it is going to change? Earlier, it is going to be in the stationary phase. So, stationary object, when it changes its position, we call it as motion, and it is also described in terms of displacement, distance, velocity, acceleration, time and speed. Okay, if you all remember, we have discussed all the terms in part 1. So motion can be described in terms of displacement, distance, velocity, acceleration, time and speed. Okay, you can even say motion is the change in position of a body with time. So when a body changes its position, so with time, that is also we know it as motion. Okay, so motion can be described in terms of distance moved or the displacement. How can we describe motion? In terms of the distance it moved or the displacement that happened. And rotation and revolution of the earth, continuous expansion of the universe, ball rolling down the hill, train traveling along the track, these are all example of motion. Now through this slide, you might be clear with the definition of motion, like what exactly motion is, and the other thing that you might be clear with is like different examples and what are the different definitions that you can provide for motion part, right? You can write that motion is a continuous change in position of an object with respect to a stationary object. So when a stationary object moves, now if we can see the balls which have been kept on screen, all the 4 balls, they are stationary, right? They are not moving. But the first ball, it was also stationary, but it had changed its position, right? So that is motion. So the first ball is showing the motion, whether rest all 4 are stationary. Okay, so we can even say that motion is change in position of a body with time. What it is? Change in position of a body with time, and we can even describe that in terms of distance or displacement, velocity, acceleration, time and speed. And different examples are given: train traveling along the track, ball rolling down the hill, continuous expansion of universe. Okay, then rotation and revolution of the earth. So this is a very important slide, because when we proceed with the further part, if you remember, we have many examples to study, we have many activities to discuss further, right? So you should be clear with this basic part, and then only you will be able to like understand those. So now I want you all to write, take a note of all the important statements that you find over here, everyone, and please be quick as well. I hope everyone of you are taking a note of it. I hope every one of you are doing it. I hope every one of you have taken note on with respect to what exactly motion is, and this is how you have to describe in detail. Now the next part that we have is motion along a straight line. So as you can see, you have a straight line along with a measuring scale which has been given starting from 0 to 60, right? So see, when an object moves in a straight line with respect to the observer, then the motion is called a straight line motion. So it is with respect to observer. Suppose I am the observer, and if you walk in the straight line, okay, then that will be known as straight line motion. Suppose you have a line which has been drawn, I am observing you, and when you walk in that straight line, that is going to become straight line motion. Okay, now let's say here they have explained, if a body starts from C is over here, if a body starts from C, goes to A till here, so it means from 25 where it goes to A, that is 60, the distance, and then come back to C again. So from once what happened, it went from C to A and then from A to C again. Then the distance covered is 35 kilometer plus 35 kilometer, because 25 to 60, what is the distance between them? 35, right? So once you're going there and then returning back, so 35 plus 35 kilometer becomes equal to 70 kilometer, and its displacement is 0 kilometer, because it again came to its rest position, right? So that is why we say that its displacement is 0, but the distance traveled by them is 70 kilometer. Okay, so I want you all to please go through it quickly. You can write this example in your own words explaining how the displacement is 0 and the distance is 70 kilometer. I hope everyone is explaining it in your own words. Okay. Now see, here we have activity 8.1, but before that I hope every one of you have understood this part, how motion along a straight line means, and you have written what exactly it is. You have to write the statement, okay? When an object moves in a straight line with respect to the observer, then the motion is called a straight line motion. Okay? After this, I hope every one of you are writing it, because we have an activity after this that we will be discussing more. After this, as I told you, we have an activity 8.1 to discuss. We are going to discuss this as well. See what is given. Take a meter scale and a long rope. So if possible from your end, you all can take a meter scale and a long rope. After that, walk from one corner of a basketball court to its opposite corner along its side. What will you do? You will walk from one corner of the basketball court to its opposite corner along its side, and then measure the distance covered by you and the magnitude of displacement. What will you do? You're going to measure the distance covered by you and the magnitude as well, and the magnitude of the displacement, and you have to check what difference would you notice between the two in these cases. Okay, so now I'll let you know what will be the difference, but before that I want you all to try it by yourself. I hope I hope everyone is going through it. You have to try it by yourself, and then only I'm going to explain it to you all. I hope everyone is at least trying. I hope every one of you is like at least trying to explain the activity. Like you have to write the explanation to it. You have to even write what conclusion you can come up with. Okay? So see, what observation will be like you will have. You can write that the distance measured from walking through the corner is more than the measured displacement. What will be your observation? The distance measured from walking through the corner is more than the measured displacement, and you can have like an explanation for it. So you can write for that, like I'll just draw something which will help you. Suppose this is the basketball court. Okay. So see, the distance is the total path length covered by the object, right? This is how we define distance. What is distance? The total path length covered by the object, right? So here, if we move along the corner, the total distance covered will become the length of the court and the breadth of the court, which is equal to, now let's say the breadth is, it's 94 feet and it's 50. Okay, then this is 106. Let's say this is an example that I'm taking. Okay, 106.47 feet. Now as you have to explain it, you will have to give this. Okay, now because we are finding the total distance covered, what will be over here is you will have to add the length of the court and the breadth of the court, which will be equal to 94 plus 50, right? Because the length of the court is 94 and the breadth of the court is 50. So you will get the answer as 114. So that is how you will be calculating the total distance covered. Then you have to calculate magnitude as well. So magnitude of displacement is the shortest possible distance between 2 points. What I said, magnitude of displacement is the shortest possible distance between 2 points, and here it represents the diagonal length of the chord. Can you see the diagonal where I have written 106.47? That becomes the magnitude. So by Pythagoras theorem, it will become equal to 106.47 itself. So total distance covered is 94 plus 50, which is equal to 114 feet, and the magnitude will be equal to, according to Pythagoras theorem, it will be equal to 106.47. Okay, and the inference that we can come up over here is displacement is a vector quantity. It means it also has direction, right? So if we label the corner of the court as A, B, C and D, and a person walks from A to C, then the direction of the displacement will be A to B. Got it? So now I want you all to like properly explain the observation, explanation and inference, that is conclusion to this activity, and you can draw the figure that I have drawn and show, like you can calculate the total distance covered and everything. I hope everyone is not finding any issue in writing the observation, conclusion, and explanation as well. For explanation, you can draw the figure that I have shown, so that it becomes easier for you. I hope everyone is writing it. Please be quick with it. After this, now the next thing that we have to discuss is again an activity 8.2. Now see what is the activity all about. Now automobiles are fitted with a device that shows the distance traveled, right? If you have like seen the car properly while your dad might be riding it or driving it, you can just ask him to show you, like, the car has a device, or any automobile has a device which has been attached, which shows us the total distance traveled. Okay, so such a device is known as odometer. What do we call it as? Odometer. So a car is driven from Bhubaneswar to New Delhi, and the difference between the final reading and the initial reading of the odometer is 1850 kilometer. It means the distance between like Bhubaneswar to New Delhi is 1850 kilometer. That has been shown by the odometer, right? So now find the magnitude of the displacement between Bhubaneswar and New Delhi by using the road map of India. So what do you think? How can you find out this? So for this you need to have a roadmap. Okay, you can just open it if you have it. So if you will see the map, you will find that if New Delhi is over here, I'll just show you. If if New Delhi is over here, Bhubaneswar is going to be straight like this, somewhere here. Okay, it's the distance is more. So what explanation you can give over here is, for like, normally you can write the magnitude of displacement between Bhubaneswar and New Delhi is around 1400 kilometer. What is the magnitude? Is around 1400 kilometer. And what explanation you can give is, magnitude of displacement is the shortest possible distance between 2 points. What I said, magnitude of displacement is the shortest possible distance between 2 points, and the roads of a city are not linear and change its shape as per terrain, right? We know all the roads are not straight. We keep on changing like the direction of our car or whatever vehicles that we are using according to the terrain, right? For example, while climbing a mountainous region, road is circular and sometimes it's linear. So what is happening? The route is changing. Sometimes the route will be linear, sometimes it will be like circular, right? So the route keeps on changing. So the only possible shortest distance is through the air, and that is why if you like use if you use airways to go somewhere, it takes very less time and you reach, like, it is the shortest distance that has been covered by the air. So we can get the magnitude of displacement by placing a thread between the point on a road map and compare it with the scale given on the map. How are you going to find it? We can get it by get the magnitude of displacement by placing a thread where between the point on a road map and compare it with the scale which is given on the map, and that is how you will find that the magnitude is going to be 1400 kilometers only, whereas the road distance traveled is 1850 kilometer, but the distance between New Delhi to Bhubaneswar is only 1400 kilometers. So the inference or conclusion that you can write over here is, the city shows the magnitude of displacement between 2 points is either equal to or shorter than its distance. What you will say? It is either equal to or is going to be shorter than the distance that it has traveled. Okay. I hope everyone is like writing the observation, inference and all. After this activity, like let's see what we have. We have uniform and non-uniform motion. So I hope you all have understood activity 8.1 and 8.2. After this, now we have uniform and non-uniform motion. So I won't start this today. We will be discussing about uniform and non-uniform motion in the next class. But I hope like whatever we discussed today, that is about describing motion, whatever we discussed in detail about what motion is and what are the different examples of motion, each one of you are clear with it. Yeah. So we described motion in detail today. Then we discussed on like how motion can move along a straight line, right? So we have even discussed on that as well. After that, we discussed on activity 8.1 in detail, and we had activity 8.2 as well. So I hope every one of you are clear with both the activities that we have studied so far, because activities teach us a lot. They help us to understand the concepts very well as compared to understanding the concepts itself, because here you're using your brain and trying to find out the magnitude, trying to find out the distance and all, right? So I just want you all to please go through whatever notes you have taken in your book. Then I'll just show you, like we will discuss the whole lesson and then we'll proceed further. So after this, as I told you that we will be discussing on uniform and non-uniform motion, right? So I'm not going to start this today. I'll be starting with uniform and non-uniform motion in the next part, but make sure, like, if you remember in part 1, while I was giving you the introduction to the lesson and we studied on some basic points with respect to it, that time even I have explained you about uniform and non-uniform motion. So I hope you have some idea on it, right? So we'll discuss about them in detail. Then we'll be discussing on activity 8.3 in detail again. Okay. After this activity, we will be discussing on measuring the rate of motion, which is again very important. How exactly we can measure the rate of motion, and that also we are going to discuss it with through different examples. If you can see figure 8.2, we have different examples, and like by discussing on through examples we will understand the concept of measuring the rate of motion. Okay, then after that, like here we have the formula of average speed, like how exactly we can calculate the average speed, and that is by the formula as total distance traveled upon total time taken. And if you know the total distance traveled and the total time taken, calculating the average speed is easy. Okay, then we'll discuss on this example 8.1, how can we calculate the average speed using the formula. Then we'll discuss on speed with direction. So it can be linear direction or it can be circular, right? So we'll be discussing on that as well, like speed with direction in detail. Then we have activity 8.4 that we will be discussing in detail again, along with observation, explanation and conclusion for it. Again we have activity 8.5 which we will discuss in detail again. Then we have example 8.2. Here we will be calculating the average speed of the car again. So by like going through this examples, you'll understand properly like how to do the numericals, because now you will be having numericals and like for science as well. So you'll find sometimes that when you study physics, you're studying maths and science. Okay, but don't get irritated. It's easy. So make sure you're not getting irritated. Otherwise, it will be in your mind forever. Then again we have activity 8.3. Here we will be calculating the average speed as well as the average velocity. Okay. Then after that we will discuss on in detail about the rate of change of velocity, how exactly it keeps on changing, what are the different factors that change the velocity. Okay. Then after that we'll discuss on acceleration in detail. Then after acceleration we have activity 8.6. Now here we have some examples like everyday life examples which have been given, and going through them you'll come to know like different types of motions from here. Then we'll discuss on example 8.4. Here we will be calculating the acceleration. Okay, so previously we were calculating the average speed, but we have to calculate acceleration as well, so we'll be calculating that. After that we will be studying about the graphical representation of motion, like if you have the data with you, how can you graphically represent that data, that is also very important, right? Then after that we'll discuss on distance time graph. Okay, now this distance time graph and graphical representation of motion, they both are important. So we'll discuss on distance time graph in detail, and here if you can see we have different examples and the formulas which have been given, which are like you will be learning as well. Okay, so before like first we will study distance time graph, after that we'll study velocity time graph. Distance time graph is separate and velocity time graph is different. So make sure you're not combining two of them, because many students they get confused with it. Okay, then after that we'll discuss in detail this activity 8.7, 8.8. Like you're like it's very important for you to go through the activity and you knowing the observation and conclusion to it, you knowing how to calculate that. Okay, then we'll discuss on equation of motion by graphical representation motion. So if you can see over here, there are so many formulas which have been used for velocity and all. So we'll be like discussing exactly the equations of motion and how like by graphical method how can we represent them. Okay, After that we have like equation for velocity time relation as well, like how velocity and time they have a relation between them and what kind of equation we can come up with that. Then we have equation for position time relation as well, like a relation between position and time, and we are going to graphically give, like we are going to give an equation for that. Then we have equation for position velocity relation. We'll discuss on that as well, like what kind of equation can be given for position velocity relation. Then we have example 8.5 in detail, like the solved example that has been given, and you'll get an idea like how to calculate this. Okay, then again we have one more example for calculating the acceleration and the distance covered by the car. Here we will be calculating the distance it travels during the time. So there are so many solved examples which have been given. We are going to discuss them all. And then we have another topic as uniform circular motion to discuss in detail. Okay, then again we have an activity, and then we have the summary discussion of what exactly we have discussed in the whole lesson. So we will be doing the summary discussion as well in detail. Okay, and after completing with this summary discussion, we have few exercise questions as well, which we are going to discuss on. Okay, so make sure we know it. Okay, so I'm going to show you the questions one by one. Every one of you please go through it quickly. I hope every one of you are going through the question. I hope every one of you are going through the questions given. So this is how we will be discussing on the 10 questions after we complete studying about the lesson motion. And I hope like every one of you are clear with whatever we have discussed till now in the whole lesson. So I'll be continuing with the rest of the part for the lesson in the next class. Thank you everyone.